Hello. Today we are going to discuss the topic of the association mining, data mining. This is the very common rule that is used to associate different strings with each other and find out the meaningful combination. In association mining, the finding frequent pattern association, correlation, or causal structure among the set of items or objects in the transaction database and other information flow. Likewise, when we visit a certain mall, there we find out that all the related things are placed next to each other so that the customer can get a easy access to these things and end user intend to think buy the thing which are related to each other even until it was not intended to purchase those things. To find out the things which are related to each other is done with the help of finding the association rules. In association rules, we find out the frequent items set which occur together, and we can apply this in the field of e-commerce and CRM. For example, uh, in the given transaction, there are 8 transactions, and they contains different item in it. We find out the rules which will predict the occurrence of item based on the occurrence of the other item in the transaction. So basically we are finding out or finding out the relation between the items and how much are they are connected with each other. For example, in the given table, we can see that the bread and milk, which are such an item, which are most frequently purchased together. Whenever bread is purchased, the milk has also been purchased. Similarly, the soda and the chips. The soda and the chips are most of the time in the series comes together. The table comes together. So we can say that these things are related to each other to a certain extent, to a limit, at an extent, and the same for the bread and jam. So here the list is just containing the 8 items, and with increasing number of item and increasing of number of transaction, it has become quite complex job to do it manually. To find a technical and mathematical approach to find out the or compare the level of association between different things, we need the help of the association. So first, we shall define the following terms, which measure the frequency of the items. There's the item set. We shall list out the total number of items that are in the list or that are here for a k item set. Then there are k number of items. The most common terms that comes next to it is support count. Support count is basically the frequency of occurrence of an item set. I'm telling you item set. For example, milk and bread. Milk and bread comes together for milk and bread comes together here in the list. We shall check out that how many times they comes together. So there are basically 3 times that milk and bread have been purchased. So the frequency, that the number of times of total transaction, number of transaction in which milk and bread have been purchased is 3 years. So the frequency is given by the row of represented with the symbol row. And similarly for soda and chips, the frequency is 4. So the support count. The support count is just the frequency of the item set. Next is the support. Fraction of transaction that contain an item set of the, this fraction here means number of transaction that contains the item set upon the total number of transactions. So here there are total 8 number of transactions. So support here is equals to 3 by 8, and support for soda chips equals to 4 by 8. And frequent items. An item set whose support is greater than or equal to a minimum support threshold is called the frequent items. Frequent item set. Uh, we decide that what will be the minimum support threshold, and all the items with support greater than that will be considered as the frequent items. Then comes the association rules. Two items associate with each other by the following symbol x to y, where x and y are the item set which are associated to each other. For example, bread is associated with milk. The These things, rule evaluation can be measured in mathematically like this, where support is the fraction of transaction that contain both x and y upon total number of transactions. So that was equals to 3 by 8, that's equals to 0.38. And the confidence, confidence is the terms which measure how often item in y appears in transaction that contains x. Here thus y is the second item which is associated. So here in case of bread and milk, we shall find out the frequency of the time when bread and milk has been purchased together to the frequency of the transaction in which bread has been purchased. For a transaction x to y, where x and y are items set, the confidence is equals to frequency of x to y upon frequency of x. So in here, the in last table, the bread has been purchased in four four times, has been purchased four times. So and the frequency of bread and milk was 3. So 3 by 4. So it would be equals to 3 by 4 equals to 0.75. Okay. The support and the confidence. So graphically, this can be represented by the time x. Uh, Support and confidence can be represented by the circle marked in black will represent the customer buying bread, and in orange circle will represent the customer buying milk, and the intersecting part represent the customer buying bread and milk. The Given a set of transactions, the goal of association mining rule is to find out all the rules which have support greater than minimum support threshold and confidence greater than minimum confidence threshold. So all the we in association rule we find out the item set which have support and confidence greater than the minimum support threshold and minimum confidence threshold. To find out threshold is can be done in two ways. First one is the brute force approach. In brute force approach, that we list all the possible association rule, compute the support and confidence for each rules, prune out the rules that fails the minimum support and minimum confidence support. The brute force approach is computationally probative because as the number of items set increases, it becomes very cumbersome job to find out the support and confidence for each one manually. Uh, because, for example, uh, suppose we are taking three items: bread, jam, and milk. Just with just three items, we can there can be following combination of the association: bread jam with milk, milk jam with bread, bread with milk jam, jam with bread milk, and milk with bread jam. Here we can find out that the support for when the item set is same is, is all 0.4. So the support or the frequency of the transaction that contains these three to the total number of transactions will be the same, but the confidence varies from combination from one combination to the other. So the rule is that if item are same, then confidence will be the same, but but they can have different confidence. And for brute force approach in which we find out every combination, it will be not easy one to find out all the values. In it, first we find out all the item set whose support is greater than the minimum support, and we find generate high confidence rule from the frequent item set, and each rule is a binary partition of the frequent item set. Frequent item set generation is computationally expensive because finding out every combination is very cumbersome job. For example, if there are 5 items, then different combination can be like this, and by counting all these we find out that with help of d item there could be 2 raised to the power d possible candidate item set. By taking one item set, we can calculate it by using the simple combination theory. Like for every item, either we can take it or uh, ignore it. So for each item, there are 2 options: taking item or leaving the item. So the total combination would be 2 raised to the power d, and it is not very efficient approach, and it's very expensive when the number of item increases. So in brute force approach, each item set in the lattice is candidate frequent item set. Count the support, and finding out the support and confidence for each one will be the more complex. So its complexity would depend upon 2 raised to the power, would be in proportion of 2 raised to the power d. So the first of all, we should reduce the number of candidates. So, uh, so to reduce the number of candidate set, we use the number of transactions and reduce the number of comparison. So before going to the, then came the algorithm, a priori algorithm, which solved the problem. In a priori algorithm, if an item, it uses a rule that if an item is frequent, then all of its subset must also be frequent. Or if item is not frequent, then its superset will not be frequent. A priori principle holds due to the following property of the support measures. For example, if x is subset of y, then support of x would be the greater than support of y. Support of an item set never exceed the support of its subset. It means support of the item set never exceed the support of its subset. Uh, this is known as the anti-monotone property of support, because the support is the frequency of the item set upon total number of transactions. So uh, definitely, because it is an obvious rule, because if item does not occur frequently, then its superset would not be the frequent one. And in a priori algorithm, if item is not frequent, then the combination which are generated by including that association or superset of that component will not be frequent, so we can prune out that supersets. In this way, the brute force is modified and we get a better algorithm that's called the a priori algorithm, because all the item set which do not support the minimum support. For example, in here, by taking a single item and with minimum support count 4, we find out that there are these items, teeth, cheese and yogurts, do not support the minimum support count, so they are truncated, and the 2 item set is smaller in comparison to the 10 item set in the table 1 of 1 item. And here we are just left with the 8 element item sets, and for the 3 it reduces to the 4. It reduces to the single. So a priori algorithm is the algorithm that is used to find out the all possible association rules by modifying the brute force approach. The algorithm is as shown here. For k equals generate for k equals to 1 means for single item set, generate the frequent item set of length 1. Repeat until no new frequent item set are identified. Generate k plus 1 candidate item set from the length k frequent item set, and prune candidate item set containing subset of length k that are infrequent, and count the support of each candidate by scanning the DB and eliminate candidate that are infrequent, leaving only those that are frequent. Means first create single item set and terminate or eliminate all the item set which do not support the minimum support count, and then by combining these two, get a k plus 1 candidate item set, and in which do not support the minimum support count, eliminate those, and then find out the k plus 1 plus 1 candidates item set, and likewise until we get the item set with support count greater than minimum support threshold. So this is the program for a priori algorithm, and so that's all. Thank you.